Welcome to Opulenta.ai. I am Opulenta. Today I want to talk about understanding the problem of finding the shortest distances between every pair of vertices in a given edge-weighted directed graph. But before I do that, let's clear up some words. Do you know the meaning of vertices, edges, directed graphs, and shortest distances? Vertices are corners. The singular of vertices is vertex. For example, a cube has 8 vertices and a cone has 1 vertex. Vertices are sometimes called corners, but when dealing with 2D and 3D shapes, the word vertices is preferred. A cube has 8 vertices. Any corner in a shape, or anywhere in a drawing, is a vertex. This means that triangles will always have 3 vertices. In the images above, all the red and pink points, which are all the points in the image, are vertices. In graph theory, a graph consists of 2 main components, vertices and edges. Vertices, also known as nodes, are the fundamental units that represent entities or points in the graph. For example, in a social network graph, each person could be represented as a vertex. Edges connect vertices in a graph and represent relationships or connections between them. In an edge-weighted graph, each edge has an associated weight or cost. This weight could represent various factors such as distance, time, or any other measure of importance or cost associated with the connection between the vertices. A graph, denoted as G equals V, E, consists of a non-empty set of vertices or nodes V and a set of edges E. A vertex represents an endpoint of an edge. An edge joins 2 vertices A, B, and is represented by a set of vertices it connects. Here V is vertices and A, B, C, and D are various vertex of the graph. What does edge-weighted mean? Edge weights. Both directed and undirected edges may be weighted or unweighted. A weighted edge is like a tollway. It costs a certain amount to travel along that edge in either direction. An unweighted edge, on the other hand, is like a freeway. It costs nothing to travel along that edge. A directed graph, also known as a digraph, is a type of graph where the edges have a direction associated with them. This means that the connection between 2 vertices has a specific direction, indicating that it is only possible to traverse the edge in that particular direction. Look at the following table. See the difference between a vertex and a directed edge. A vertex and a directed edge are 2 distinct components of a graph. Here's an explanation of each. A vertex, also known as a node, is a fundamental unit in a graph. It represents an entity or a point. For example, in a social network graph, each person in the network can be represented as a vertex. In a road network graph, intersections or junctions can be represented as vertices. Vertices are typically depicted as points or circles in graphical representations of graphs. An edge is a connection between 2 vertices in a graph that represents a relationship or a connection between them. In a directed graph, an edge is called a directed edge or an arc. It indicates a one-way connection or a directed relationship between 2 vertices. It has a specific direction associated with it, indicating that it is only possible to traverse the edge in that particular direction. To illustrate this, imagine a directed graph representing a transportation network. Each city is represented as a vertex, and the directed edges represent the transportation routes between cities. If there is a directed edge from city A to city B, it means there is a transportation route that allows travel from city A to city B, but not necessarily in the reverse direction. In summary, a vertex represents a point or an entity in a graph, while a directed edge represents a one-way connection or relationship between vertices, indicating a specific direction of traversal. The shortest distance between 2 vertices in a graph refers to the minimum weight or cost required to travel from one vertex to another. It represents the most efficient path or route between the two vertices based on the weights of the edges. The problem involves finding the shortest distances between every pair of vertices in an edge-weighted directed graph. In other words, you want to determine the minimum cost or weight required to travel from any vertex to any other vertex in the graph, considering the directions of the edges. There are several algorithms available to solve this problem, with the most well-known being the Floyd-Warshall algorithm and Dijkstra's algorithm. These algorithms use different approaches to calculate the shortest distances efficiently and are commonly used in various applications, such as network routing, transportation planning, and pathfinding in video games. Dijkstra's algorithm finds the shortest path between a given node, which is called the source node, and all other nodes in a graph. This algorithm uses the weights of the edges to find the path that minimizes the total distance, weight, between the source node and all other nodes.